Skype parallel programs typically executed on commodity nodes. HIPPY also provides integration with OpenCV. Chains have been made to the HIPPY interfaces classes such as float image, HIPPY image header, and image codec classes in this work. Figure illustrates the general architecture for future extraction tool. Hadoop framework stores satellite images in HDFS, Hadoop distributed file system, and the data is distributed among several data nodes. Blue box represents the HDFS. HIPPY uses HIP bundles to store images so that each mapper is provided with a single image. In future extraction phase, local features are extracted from satellite images in the HIP bundles. HIPPY interface allows each image in HIP bundle to be processed by individual mappers. Each mapper extracts local features and descriptors using aforementioned algorithms. For example, for health detector, a map function is as shown. The images in this study were taken from recently launched Landsat 8 satellite. All experimental results are obtained using 2 and 4 commodity machines for multi-node cluster computation and one node differently to show scale-up behavior of algorithms. Table shows the horizontal scalability analysis of algorithms and indicates here number of mosaics. First figure illustrates the corner detection algorithm C-Tomasi detector, and second one illustrates future descriptor SURF. To sum up the presentation, we introduced distributed feature extraction and description tool for high spatial resolution remote sensing images. The proposed tool is based on Apache Hadoop with HIPPY. Some well-known feature extraction algorithms and feature descriptors are implemented. Scalability analyses of all approach show that increase in working times are observed with an increase in the number of images. Thank you.
Okay, thank you very much, Sulaiman, for your presentation.
Again, thank you very much, Sulaiman, for a very good presentation. Yeah, is there any question? One question, yeah, from Yildiz Technical University.
Thank you for your presentation. As I saw from your presentation, you benchmarked your method with another interest operator methods. But did you make any accuracy assessment? I mean, by comparing another methods, the matching quality, matching accuracy, about the matching accuracy and another local, about local position. Did you make some accuracy assessment?
In the future, we will make some performance metrics, as you mentioned, accuracy metric. Now we didn't perform any matching accuracy metric. Okay. Now. Thank you very much.
Any other, one last question? If we have, mention your name and then your affiliation. One, two, three, no. All right. Thank you very much again to Sulaiman. Now I would like to call upon the next speaker. First of all, I would like to check. Is there any person called Vincenzo Barrio? No. Then we go for the next speaker by Kasim Uzacha. He'll be talking to us on a low-cost and lightweight 3D interactive real estate purpose indoor virtual reality application. Please welcome Kasim Uzacha.
Just a moment, please. Okay. Hello everyone, this is Ozir Kasim from Cardiff University. Today I'm going to talk about a low-cost 3D application for virtual reality using Unity 3D game engine. The main idea is actually to buying a property using a 2D plan. Let's say purchasing a property of the plan has some limitations. You have money, you want to buy a house, but you have 2D plan because there is no structure built before. The problem is we cannot imagine the complete architecture. We have no idea what's going to happen if you buy it. It might not satisfy the expectation of us. So, but to solve this problem, there could be a visualization in which interior interaction of the property should be demonstrated. This could be a way. There are several ways to do this, to realize this. First of all, to make a demonstrative real property. Let's say you want to buy a 2+1 room house, and there are many of them. The property seller cannot demonstrate them, can only show the one. If you want to buy another one, another version of the house, you cannot see them because there's one single demonstrative real property. The other way could be a 360-degree panoramic view again. It's also you have to build a house and you have to let the user look at them. But again, the limitation about them is clear. First of all, it's expensive, you have to build, and it's limited. You cannot see every detail in the structure. Another way to do this is a 3D immersive visualization in which it real-time render the interior of the architecture. And user can visualize interior, they can walk through, and they can interact with the content. For example, you can modify the walls and the floor or anything you want. But the problem with this 3D immersive visualization is actually, it's clear. Creating such environment requires specialists, 3D modelists, and highly resource-consuming software such as 3D Max, SketchUp, Blender, and so on. This is not good for a novice user, for the beginner users actually. So, in order to solve problem, we have a set of methods or set of software which are free. We are going to propose a low-cost, high-quality, fully interactive virtual reality application, which is totally interactive, provides us a realistic interior architecture. So we have two main tools, which is Sweet Home 3D and the other is Unity 3D 5. And what else we need is a head-mounted display in which we are going to demonstrate what we prepared using these two software. Let me go in detail about the software before explaining the previous work. There are some previous work regarding this. There are many actually written in the paper, but I want to say that the problem about them is they are whether lack the interaction or they designed in commercial and heavyweight software, or they do not present realistic 3D view. So in order to solve this, we are going to use two application and one hardware. First of all, is Sweet Home 3D. The good thing about this software 3D, it's free, and we can create a 3D model in a few steps using a 2D interface. The other one is Unity 5. This is good to make this interactive, this content interactive and make it realistic, and finally deploy it for head-mounted display, which is HTC right here. So let's go in deeper about for the Sweet Home 3D. Sweet Home 3D is quite simple application. Again, it's free software. We can draw walls and floor in 2D window, which is very simple, and we can, again, in real time, we can visualize them in 3D view. There's a split screen on the view, so here, as you write them, you can see the content in 3D view split screen. The other feature is you can apply the texture, you can drag and drop the objects in the scene, you can color or you can apply material on screen. So there's a video I prepared to just write step by step the 3D model creation here. This is the floor plan. You can just get the bias, for example, and you can have a wall. Now I can just draw a floor, and I'm building the wall, and you can see the construction in 3D view in real time. You don't have to be special. You don't have to be a architecture, or you don't have to be a 3D modeler to make this. So let's add some door, and we can add some window. It's very simple, again. And you add it, and you see that in the 3D view, it's very simple again. So you can change the look to better see the content again. Let's add some window. So you can complete this in this software easily, and then you are ready to export to Unity 5. It can say your object is OBJ format, then you can export to Unity 5. So let's go to the Unity 5 part. This is actually a game engine. I think most of you know this. It's a very famous game engine. It's again for free. It can provide you cross-platform application. Let's say you write in your game in Unity 5, you can deploy it to Android.